Kiddos, this is angles and triangles number 7. Yesterday we learned about 2 ways to prove that triangles are congruent. We learned about side, 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 and we learned about side, angle, side. Today we are going to add on 3 more ways to prove that triangles are congruent. So the next one is angle, side, angle. And just like side, angle, side, where the angle had to be sandwiched in between the 2 sides, this time the side has to be sandwiched in between the 2 angles. So you can see in my diagram here, I have 2 angles right in a row, and it's the side in between. 2 angles in a row, and it's the side in between. So we can say if angle A is congruent to angle D, side length AB is congruent to side length DE, and then angle B is congruent to angle E. That's going to give us an angle side angle. And then we can say that triangles are congruent. Remember, order matters. So if I name this triangle ABC, then that is going to be congruent to triangle DEF. All right, so let's use this to write ourselves some proofs. Please remember that you always start with the given information and you always end with the proof. So my given information, SQ bisects angle RQT and angle RST. There's my first statement, and this was given information. My proof statement, triangle is congruent to triangle, is right down here in number 5 at the end. Okay, so let's go ahead and go through this. It says that SQ, this line right here, bisects angle RQT. So remember what that word bisects means. It means to cut in half, to cut into 2 equal pieces. So if I'm cutting this angle into 2 equal angles, that little one and that little one are congruent to each other. I can't name those angles Q because there's 2 different angles at Q. So this one I'm going to have to name RQS, that's that one. And this one is going to be TQS, that's that one. And what allowed me to know that those 2 angles were congruent to one another? It's because of that word bisects. We knew the definition of bisects or bisector. Also, it says that SQ is a bisector of RST. So here's angle RST. And if it's bisecting, that means it's creating 2 equal angles. I can't call them angle S, I have to call it angle RSQ, that's that one, and angle TSQ, that's that one. Same reason, we know the definition of an angle bisector. Remember from yesterday, we were looking at when 2 triangles share the same side. That leads me to say that QS is congruent to QS. And do you remember the property? It is the reflexive property. So now that is enough information to say that my triangles are congruent. Just like yesterday, I'm going to cover up. I'm going to go one at a time. So I have angle, side, angle, angle, side, angle. So it is proven angle, side, angle is what we are using to prove that triangles are congruent. All right, let's do number 2 together. So JK is parallel to LM and JL is parallel to KM. So they put it in the same statement that time. This is given information. And now we need to label it. So JK, little triangle, is parallel to LM. So let me use that right now. So if I have these two parallel lines and they are cut by a transversal, it's going to make this angle and this angle congruent to one another. So what is that? That is angle JKL, so that's that one. And then angle MLK, that's that one. What relationship, what angle pairing is this inside of parallel lines and on opposite sides of the transversal? What do we call that? Those are alternate interior angles, and we know that alternate interior angles are congruent. All right, let me label the other one. I'm going to switch colors. So now I have JL parallel to KM. So I'm going to switch colors. This time, these are my two parallel lines, and I have the same transversal. Do you see the angles which are congruent? It's this guy and that guy. They are located in between my parallel lines. They are on opposite sides of the transversal, which means they are congruent because they are, let me check it, JLK, yep, and then MKL, yep, okay. So those are the same. Those are alternate interior angles. All right, what else do you see? Well, right down the middle, shared by the top triangle and the bottom triangle, KL is congruent to KL. That is the reflexive property. And now that gives me enough information. Cover up, look at one triangle at a time. We've got angle, side, angle, and then angle, side, angle. So confirmed angle, side, angle. All right, on the back side here, I want you to try this one on your own. Pause me and see if you can work through that one on your own. All right, my given information, I've got angle BAC congruent to angle DEC because it's given. I have another one, C is the midpoint of AE, that's given. Those are all my givens, and now I can come down and write my prove statement. Triangle ABC is congruent to triangle EDC. All right, so I had 10 spots to fill out, and I've already got 5 of them filled in. We are currently halfway there. All right, now what? Well, now I'm going to mark up my triangles. So angle BAC, so that one, and DEC, that one, are congruent to each other. That's given. C is the middle of AE. So if C is in the midpoint or the middle of AE, what am I allowed to say? AC is congruent to CE. AC is congruent to CE. And how did I know that? I knew that because C was in the middle, and what we have is definition of midpoint. All right, maybe you got stuck right here. You have to see it. Do you see this X being formed? What do we know about angles in an X that are opposite of each other? Those angles are congruent. So I'm going to call that angle ACB congruent to angle ECD, and those are vertical angles. All right, now if I cover up a triangle, what do we got? Angle, side, angle, angle, side, angle, angle, side, angle. All right, let's add another one on. So another way to prove that triangles are congruent is by using angle, angle, side. Angle, angle, side. So this time we're going to have two angles in a row followed by a side. Notice how the side is not in between those angles anymore. That would make it an angle, side, angle. So the two angles are together and then the side. So this says, if angle A is congruent to angle D, and the next angle B is congruent to angle E, followed by side BC congruent to side EF, then I can say that those two triangles are congruent. So triangle ABC would be congruent to triangle, same order, DEF. All right. I bet you can do this one on your own. Try it. Pause me. First statement, YZ bisects angle WYX given. Angle YWZ is congruent to angle YXZ given. And the proof, triangle WYZ is congruent to triangle XYZ. So here we are, we're at the halfway point again. All right, mark it up. So this says that YZ is going to bisect, cut in half, angle WYX. So if we are cutting that angle in half, that means that this angle and this angle are congruent to one another, which means I can write angle WYZ is congruent to angle XYZ because, how did I know that? Because we knew the definition of bisector. All right, what else are your eyes peeping out? See our two triangles share this side. What does that mean? That means that's congruent. So YZ is congruent to YZ, and that's because of the reflexive property. But wait a minute. If I look at one triangle at a time, I've only got an angle and a side. An angle and a side, that's not enough information. I need three pieces to be able to prove congruent. Well, didn't I forget to label that one on my diagram? I sure did. I did the bisects, and that brought me down here. And then I saw the reflexive, and I got excited, but I totally skipped marking this one. So let's mark this one. We've got angle YWZ, so that one, congruent to YXZ, that's that one. Now I've got my three pieces. I've got two angles in a row and then a side. Here, two angles in a row and then a side. So this is angle, angle, side. I really hope that you are trying these on your own and that you are working through them. Okay, the only way to get better at doing a proof is just by doing more and more proofs. All right, given angle ABC is congruent to angle CED, given. Next one says that AB is parallel to CE, given. We've got another one. It says that C is the midpoint of AD, given. and then our prove statement. So triangle ABC is congruent to triangle CED. All right, so let's mark all of our parts. Angle ABC, that one, is congruent to angle CED, that one. Remember, the middle letter is the angle, so angle B and angle E. It says that AB is parallel to CE. And we have that C is the middle of AD. Okay, how do I mark that? C is in the middle of AD. What does that create for me? I have two equal pieces. This one and this one are now equal to each other. So we can write AC is congruent to CD. And how did I know that? Because I knew what the definition of midpoint was. All right, do I have enough? No, I've got one angle and one side. What haven't I used yet? I marked it, but I didn't use it yet. I marked the parallel lines, but I have not used those parallel lines yet. All right, so let me highlight. So here's the parallel lines. What's the transversal? That's the transversal. Where are my two equal angles from this? Right there and right there. So what is that? Angle, I can call that angle A, but this one I have to call angle ECD. Angle ECD. What kind of angle pair is that? They're to the right of the parallel lines. They're both located on top of the transversal, so on the same side of the transversal. Those have the same location. That means that they are corresponding angles. Remember when I told you it was important to memorize that vocabulary? Yeah, really important to memorize that vocabulary. All right, so what do we have? If I look at one triangle at a time, I've got two angles and a side, and here I've got two angles next to each other and a side. So this is going to be angle, angle, side. Try this one on your own. Number 6, you can do this one. 100%, you can do this one. PR bisects angle QRS given. Angle PSR is congruent to angle PQR given. And then my proof statement, triangle PSR is congruent to triangle PQR. All right, go to your diagram and label. It says that PR is going to be bisecting angle QRS. Bisecting means cut it into half, cut it into two equal pieces, which means that this angle and this angle are now equal to each other. How am I going to write those angles? How about QRP congruent to angle SRP? How did I know that that was going to get cut in half and they were going to be two equal angles? Because we know the definition of bisector. Okay, now I need to label angle PSR. So PSR, that's this one, is congruent to PQR, that is this one. All right, but if I only look, I got two angles. I'm missing a third piece of information. Where's that third piece of information coming from? How about right down the middle? Did you see it? Did you see that PR was congruent to PR because of the reflexive property? And now, what are we looking at? Two angles in a row followed by a side. Two angles in a row followed by a side. That is angle, angle, side. All right, let's do it. Number 7. It says LG is parallel to JM, given. It says that H is the midpoint of LM, given. And then at the end, triangle LGH is congruent to triangle MJH. All right, mark it. LG parallel to JM. H is the middle of LM. H is in the middle of LM, which means LH and HM are the same. They are congruent to each other. So we're going to write LH is congruent to HM because we know the definition of midpoint. All right, I totally don't have enough stuff. I only have one side. Yikes, I only have one side. All right, well, what else can we do? Well, we haven't talked about the parallel yet, so let's use our parallel lines. So here are my parallel lines. And then we have a transversal. So what do you want to use as the transversal? We actually have two options. We could use this one as the transversal, or we could use this one as the transversal. It's not going to matter. How about this one? So if I use that as my transversal, that's going to make this angle congruent to this angle. So angle G congruent to angle J. How did I know that? What kind of angle relationship is that? Opposite sides of the transversal on the inside of your parallel lines, those are alternate interior angles. All right, sweet. Well, I'm still not there yet. I only have an angle and I have a side. I need a third piece of information. Do you see where that third piece is coming from? I hope you do. You see how we have an X? Oh, what do we know about opposite angles in an X? They are equal to each other. So I can say that angle LHG is congruent to angle JHM. And what are those angles called opposite of each other in an X? They are called vertical angles. And now cover it up and see what you got. Two angles with a side, two angles with a side. This is angle, angle, side. All right, on the back side here, I want you to note, these are the ones that we have that prove that triangles are congruent. We learned about side, 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 and then side, angle, side. Today we added on angle, side, angle, and angle, angle, side. What we talked about yesterday is that there is no swearing, angle, side, side, or backwards, side, side, angle. And there is no buddy to call when you have a flat tire, triple A. There is no triple A. So side, 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 angle, 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 side. No swearing backwards, and nobody to help you when you lock your keys in your car. Okay, so the last one that we need to talk about is hypotenuse leg. And we abbreviate that HL, hypotenuse leg. Now I want to point something out to you. When I look at this diagram, what we have is angle side side, and you're thinking, whoa, wait a minute, that's not a reason we're not allowed to swear at you. Angle side side. Yes, you are correct. This is angle side side. However, we are not going to be calling it angle side side because this is a special situation. These are right triangles, and only a right triangle has a hypotenuse. The hypotenuse is across from the right angle. That's how you find it. You go to your right angle and then you go across. It is also the longest side of a right triangle. The leg is right next door, that's what adjacent means, is right next door to the right angle. So here's the right angle, next door, that's a leg, and that's a leg. So if you have a right triangle, because that's the only one that has a hypotenuse, if you have a right triangle and the hypotenuse is congruent to the other hypotenuse, BC is congruent to EF, and you have a set of legs, AB, congruent to the other leg, DE, that means that you only need those two things to prove that right triangles are congruent. Okay, you don't need three pieces of information because technically that third piece is the right angle. All right, this is only for right triangles. So technically the third piece is the right angle. So if you have the hypotenuse and you have the leg, then you can say that triangle ABC is congruent to triangle DEF. So if you see triangles and it looks like ASS, check to make sure if it's a right triangle, you can say they're congruent, but you're not calling it ASS, you're calling it hypotenuse leg, because that is specific to a right triangle. Okay, so triangle LMP and triangle MNP are right triangles given. LM is congruent to MN given. And now we label. So LMP is a right triangle, they have it marked. NMP is also a right triangle, so I'm going to mark that one. ML is congruent to MN, and I'm going to mark that one. Now, do you see right up the middle? They are sharing this side length, which means that MP is congruent to MP. That is the reflexive property. And because these are right triangles, notice how it's angle side side, that's bad. But because this is a right triangle and we have the hypotenuse and a leg, look at this side, the hypotenuse and the leg, we can say that these are congruent because of HL, hypotenuse leg. Don't swear at me. If it's a right triangle, then use HL. All right, last one. Last one. Let's write in all of our givens. So triangle WVX and triangle YZX are right triangles given. WV is congruent to YZ given. X is the midpoint of WY given and triangle WBZ congruent to triangle YZX, that is our prove statement. So with so many givens, we're going to label our diagram. It looks like we're going to need one more piece of information, and let's see what we got. So triangle WVX is a right triangle. Well, clearly those are not the right angles. That one is. And YZX are right triangles. Those two are not the right angles. Clearly this one is. All right, move on. WV congruent to YZ. And then it says that X is the midpoint of WY. X is the midpoint, which means two equal pieces, WX and XY are congruent to each other. So there's the missing piece. WX is congruent to XY, and that's because we knew the definition of midpoint. All right, so what do we got? I've got ASS, that's no good, but it's a right triangle. So I have a hypotenuse and a leg. Over here, hypotenuse and leg. So I can say hypotenuse, leg. All right, so the last thing that I'm going to do is I'm going to go back to the end of yesterday's notes, kind of this graphic organizer here, and I am going to write in all of the things that we learned today. So we learned about angle, side, angle. So that means that you have two angles with a side in between it. So for example, first angle, second angle, side in between it. Angle, angle, side. So first angle, second angle, followed by a side. That's angle, angle, side. And then we learned about hypotenuse, leg, which would say that the hypotenuse is congruent, and then our leg is congruent. And we've seen these nice reasons popping up, right? Our reasons are because it's given. That's my favorite one. That's why there's a smiley face there. We've used the definition of midpoint a lot. We've used the reflexive property a lot. We've used vertical angles a lot. We've used alternate interior. I haven't used an alternate exterior, but it's possible that it could pop up. Corresponding angles we've used twice, I believe. An angle bisector, just definition of bisector, those things we've used quite a bit. All right, so these ones are for parallel lines only. Everything else you are looking for just in your diagram. Parallel lines are going to give you those possibilities. All right, so that means that tomorrow we're probably going to come and loop back around to this CPCTC. So you have some practice to do, work through that, and prepare your questions that you need to ask. All right, see you soon.